Hello friends, welcome to Power Electronics. Today we will discuss for the basic DC to DC converter, express the following variables as the function of source voltage and the resistor and the duty cycle alpha in case of the resistive load. So as you can see in A, the average output voltage and the current, how to calculate it. For example, if we have taken this chopper, Vs is a supply voltage, so the current start flowing through this when the switch S is closed. It flows through the inductor, then it flows through the load and to the back path. In this process, the inductor is charged with the polarity plus minus. There is a kind of drop. But when the switch is opened again, the inductor reverses polarity and it transfers to the load and the freewheeling diode starts conducting. As you can see here, this is a periodic waveform as you can see here. So what you see, how to calculate the average output of any waveform, it is the area, this area upon the t being the time period. So it means that V output upon V supply is equal to T on period upon the T. So you can see here V output here is equal to T on upon T. So this is called as alpha. So this is V output equal to alpha times of Vs. Also we can calculate the current I naught by dividing the output voltage with the resistor R. So you will get the value here. Also the output current, how do we calculate the output current at the instant of commutation? So we know that the output current is commutated by the thyristor at the instant t on. So the output current at the instant of the commutation is Vs by R. So also for the resistive load, the freewheeling diode do not comes into play. Average and the RMS value of the freewheeling diode is 0. This question is always asked in the MCQ that for resistive load the freewheeling diode do not come into play. The average and what is the average and the RMS value is 0. Also the RMS value of the output voltage. How do we calculate it? We calculate it by, if this is the area, how do we calculate? Square this area at the time of conduction, square this area, root mean square. First of square this area, so then divide it by the time period and then take its root. So as you can see in the diagram here, RMS value of the output voltage, that is T on into the supply voltage Vs. Vs is the supply voltage whole square into T on period. The